set is so small that 5% is going to be a little bit misleading. So, please, Kelly, yes?
So, in the standard deviation of the calculator says 7. So
Good.
do you round down to 5?
Well, good. Thank you for bringing this up. You read my mind, actually. Read my mind. So what I'm going to do is I'm going to run one of our stats. That's what I get. Kelly asked the question, okay, since you asked me to do to the nearest 5 pounds, should I round down around the average up to 170 and the standard deviation up to 10 and then crunch it that way? So this is a mathematician speaking now and not a statistician and not a casual user of statistics. What I would do as a mathematician is do all the calculations with all this precision and round the last result to the nearest 5. The reason for that is if you round every step of the way, you're increasing more error with every step of the way. Does that make sense? So the way I would do it, and this is why if you didn't do the quizzes for this week, I don't mind. But I taught you in the quizzes for this week, there's a cool little shortcut. Watch this, I'll show you. If you go to your VARs menu, oops, there's a statistic, let me do this clear. If you go to your VARs menu, there's a statistics menu that allows you to pull, watch this, X bar minus 2 times. I'm going quickly, this is all in the quiz posted for this week and it'll be up for the entire term. So it's there waiting for you if you want to see this, just so you know. VARs, statistics. So what this will do now, to answer your question, Kelly, which is a fantastic question, it will stick the value of 167 in right there, and the 7 point whatever it is right there, and multiply it by 2. And then when I press enter, I round that to the nearest 5 pounds, which would be 150. Is that fair?
Did you round that to 155?
Oh, I guess it would be 155, wouldn't it? Shit, it was 155. Yes, thank you, Tom, for rounding correctly. I've been a non-mathematician for far too long. 155 to the nearest 5 pounds, thank you. 150 to the nearest 10, 155 to the nearest 5. Linda, go.
Oh, kind of along with that. Just
Good. Both catching my math there. Good for you guys.
150 is lower than 150.
So, right. So that means 150 would be too low because the bottom of 2 standard deviations would be 155 to the nearest 5 pounds. Thank you for catching that before I good. So, Candace, you guessed too low for 150. Now, the cool part about this is you can press second enter and then just change that to a plus. And then press it again. And now that, look at that. That actually rounds up to 185, doesn't it? Because it crosses the 2.5 pound marker. This is where precision gets to be a pain in the ass, right? Because if you round, technically speaking, 180 to 185, the midsection is 2.5 pounds. That's right above it, so it would actually go up. So that means the 180 actually wasn't too big. So the only outlier, Candace, was you on 2 standard deviations. You said I was too light, according to the rest of the sample data and the average, if you trust the average. Is that fair? Mm-hmm. Now, those of you that said the average wasn't trustworthy, can you see that the TI identified 2 outliers? Candace, it's you again. The 150 is definitely the low one. But the 180, said,
3 outliers?
Are there 3? Oh my God, look at that one. Thank you guys are so good. There's a 3rd one. I didn't even see that over there. Bump that down to 145. There are 3, Kel, look. This one was almost off the screen. My window wasn't damn TIs wasn't showing it to me. Candace, 155 is also too low, and the 180 is too high. Then there were 2 180s. You're both too high. Holy crap. 4 outlier votes. 150, 155, and the 2 180s. Oh, that's kind of cool. That's never happened before. Usually I get 1, maybe 2, but not 4. That's 25% of you grossly overestimated my weight. Linda, what's on your mind?
Just why? I mean,
why are there 4 there and only 1 with the other way? Think about it. The calculation is different. The IQR is, again, very tight compared to the standard deviation. What's the IQR? It looks like it's only 5 pounds, right? It's only 5 pounds, which means when you take that IQR and multiply it by 1.5, now it's 7.5 pounds. 7.5 pounds is what 1 standard deviation was, and then you doubled it. So now the range is much wider for 2 standard deviations, meaning you've gobbled up more of the data in 2 standard deviations, meaning it's harder to get outside of that. The net is bigger. The net for the IQR is shorter. Does that make sense mathematically? You're casting a smaller net. So for standard deviation, the net would be here. But for the IQR, the net would be here-ish. It's a much tighter net based on the randomness of the data, just based on how the data fell. Kind of cool. Remember, Outliers, like standard deviations, like averages, like medians, these are human-made things. This is not gospel. This is why I get so excited for the back half of the course. When the dice start falling and the coins start flipping and the cards start getting pulled, because then the data just shows randomness and things start clumping and things start presenting themselves, and there's nothing human-made about it. It's all just randomness showing up on its own. At this point, we're still just dealing with formulas that we have to kind of accept. Pretty badass, huh? How'd you guys do on my average? What did you guys say again? I've forgotten now what you guys said I was. 167. You're down about 5 pounds. I'm usually somewhere between 170 and 175. Usually somewhere in the middle of that, about 172. Not bad though. I mean, not really bad. But it's interesting because my true weight is more like here, right? So on average, my true weight is actually here. On average, you did a pretty good job. Obviously, most of you said it here. But this always tends to happen. People generally guess too low. I think it's because I wear these baggy-ass clothes. I think. I'm guessing. I don't know. Maybe not. Maybe it's the hair. But cool. So that's a couple weird data sets, a couple fun data sets. I wanted to close the day by talking about some other ones with you, and one in particular. But any questions you guys have before we get into this last little wrap-up discussion? Anything bugging you guys right now about outliers? Who feels wishy-washy about them? Like, I don't know. I don't know if I like. Good. Because these are human-made things, right, Kara? They're human-made things, which means it's not gospel. It is not law. It's just what we have to quantify. We all have a gut feeling, right? We have a gut feeling when something is too big or too small. But the problem is we don't know how big too big is. If you see a newborn, that's 7.5 pounds. Is that baby too small? Based on your experience?
How what?
7.5 pound newborn.
No.
8.5 pound newborn.
No.
9.5 pound newborn.
Too small.
Get too big, maybe.
Yeah.
I was 9.5 baby. 10.5 pound newborn. Poor mother. Right? So now you see what just happened? You guys in your mind just drew a limit for outliers somewhere. All we're trying to do right now is metric that. That's all we're trying to do, right? We're collecting all those data points and throwing a line in the sand. Beyond this is too big or too small or too different. That's all. Is that fair? That's why it feels weird. Because we're trying to apply mathematics to like a gut feeling. But that's what statistics, honestly, that's what statistics kind of does. It takes your gut feeling and tries to explain it quantitatively. So, I'd like to share a couple data sets with you that I've collected over the years that